Hey everyone, it's Mark. I am starting what I hope is 2 of 2 of this Peavey Classic power amp. I've got the board out, and I don't have the new transistor in yet. I should get it, I'm thinking maybe tomorrow. But I had a little extra time, so I pulled the board and I'm going to take out the transistor, and I decided to stop and get out the camera, and I will film that process in case you don't know how to desolder a transistor. Okay, so the transistor in question is these 3 pins right here. And normally you have to be careful when soldering transistors because it doesn't take too much extra heat to burn them up. But I'm removing one to replace it, so I don't really care about heat. But you will see I'll be much more careful when I put the new one in. And all I really do is I'll just go down each pin with the solder sucker. And then if need be, I have a little bit of desoldering braid that I can use. And this is not doing the trick. Okay, and this is desoldering braid. All it does is just sucks all the solder up out of the joint. Okay, see these 2 cleaned out really nice. This 3rd one didn't, and you can tell why. That is going to ground, so there's all this extra mass that has to heat up. And I have a crappy little soldering iron, and as usual, I'm just gonna be having a little trouble getting enough heat in this joint to wick the solder out. There we go. Now I need to pop each pin up. That may require a little bit more heat, may not. Wanna be careful you don't rip any traces off though. Okay, I can tell it has come loose. There you go. All right, everyone. Now, for science, I took out the other transistor that I suspect was good, just because I wanted some reassurance so I could sleep tonight, knowing that I actually found the problem. So I have these labeled, but if I didn't tell you which was which, I will show you how to find the good one from the bad one. First, I'm going to put my meter to diode checker. See the little diode symbol there. And here is one at random. Since this is an NPN transistor, I'll hook the positive to the center, to the base, and then we'll check the collector. Forward voltage, 0.714. That is wonderful. Check the other one, 0.718. I would expect to get around 0.7. Now here's another one at random. Hook it to the center. Nothing. Hook it to the other one, nothing. And that is the one I labeled with the little dot to show that that was the bad one. So, I now know, absolutely, this transistor is the one that's bad, and when I get the new one in the mail, I'll pop it in, and that LED will work. So, I'm feeling good. Let's hope I have the same luck on the Tascam chip that I ordered. And one more quick thing. This is that fuse that I had after starting it up about 5 or 6 times. You can see the filament there. It hasn't broken yet, but it's about to. And if you're wondering the difference between the ceramic fuse and the glass fuse, I was, so I broke it open. So it's actually completely full of some kind of powder, and the outside is ceramic, so I assume the idea there is that it'd be good for dissipating heat, but it would also not explode. So I don't really know. I'll have to do some research on that, figure out why you would pick ceramic over glass. But to get a 12 amp slow blow, I had to get ceramic, so that's what's going to be going back in. Okay, now I'm done for real. Hey everyone, we are back to finally get this Peavey amplifier put back together. Thanks to my good friends at DigiKey. No, they don't sponsor me. Nobody sponsors me. I just spend enough money there that it's like they're my friends. So let's get to it. First thing you might notice is my soldering iron tip. I just have this crappy little Weller soldering iron right now, but the tip was worn out and I didn't have a replacement, but I did have a couple of brand new tips for a different iron that I think I got in a box of junk. So I modified it and I think it's gonna work, but hey, the price is right. I keep bidding on soldering irons at auctions and I never win them. Alright, I ordered a few of these because they're so cheap. And while I'm waiting for the iron to heat up, the first thing I need to do is spread out the leads to match that. That should work. And before you put in any component, other than maybe a resistor or a ceramic chip capacitor, make sure your polarity is correct. Here is the, right here. That's the one we're replacing, and you can see the flat is pointing that way. Just like that. Flip it over to the back side. Bend the pins so that it stays put. That's all there is to it. The last thing I'd like to do, just kind of as a professional touch, some flux cleaner. There, it's like I was never in there. Okay, let's put it back together. Well, somewhere in this room, there's another knob. There's a few other screws that hold this in, but I did not get them. And right there was the main culprit. 12 amp going in, because that's what it called for on the schematic. Okay, moment of truth. Yes. No light. I'm gonna let that warm up for a minute. Okay, it's been warming up. The tubes are on. I found my knob. Light on, light off. We fixed it. I'm going to plug in the microphone and the speaker here and test it out. Check, check. Well, everyone, this one's in the bag. It's hard to believe that after all those problems, this is what needed to be replaced. But it's working now. Get it back out to the customer, and hopefully I only hear good things back. Now it's time to finish up the Tascam. Thanks for watching.